So you get to college, and then you have freshman year, and then after that you go to your sophomore year, and then after that you go to your junior year, and then after that you get to your senior year. Senior year you have this class, it's called senior design, where you have to actually choose a topic that you actually enjoy or something that's complicated that you want to learn more about. We got a group of 5 people. So we all got together and started thinking about something fun that would guarantee us an A in class. And we decided to do the IEEE robotics competition. Get a robot, you build it, you program it, and you make it do the stuff that eventually gets it so it can pick up 4 boxes at each corner and bring it to the center and put it in the appropriate locations.
So couple of the requirements of the senior design project is
So part of the problem with senior design is they put a bunch of engineers in a room with Legos. That causes testing to take quite a long time because you play with them. And in fact, we actually got
Thomas, did you see this one, dude?
No. We totally got to a point where we were pulling wheels off of Lego
Thomas,
toys
dude,
and using them as a
one, dude.
robot because we couldn't come up with anything else better.
Thomas, y'all look at this Lego, dude. Some of the requirements of a senior design project is to come up with a budget and a timeline so you don't overspend and you stay on task. One of the things we'd say is by the end of January, let's definitely have the programming done, or let's have the gripper arm. That's it. That's all I'm saying. I'm done.
Alright, so the next step after brainstorming is to actually go ahead and start building your project. So we went ahead and ordered parts to build a robot. Once we had our robot built, we needed to program it and start testing. So we needed to also build a test board, which was an 8x8 foot piece of wood that we had to paint appropriately and start testing our robot.
So basically the project had several sections to it for coding purposes. We really needed to look at our project from the community impact standpoint, which meant that all of our code and programming and all of the research that we did into the project needed to be very modular, and quite a bit of the code just reads like a book. Tons of comments everywhere so that everybody can know in the future what's going on. That way we can reuse hardware, we can reuse software. Testing pretty much followed every single completed block of code so that we could get the robot to operate appropriately. We discovered quite a few things in testing, like servos not really liking working with motors since they both use a similar modulation technique. We had a lot of bugs to work out in that respect, and we just learned a lot from it.
Dude, they better be programming. The competition's tomorrow, man. We're gonna get in so much trouble if we're not.
They're sleeping. Philip.
Wake up, dog. Wake up, dude. What are you doing, man?
Dude.
Eat! Finish the code?
Not yet, man. Almost.
Beans, you finished the gripper arm?
You know, you might want to come back in an hour or so. Alright, so then it was time to go up to Lubbock for the robotics competition. The whole thing was kind of a surreal experience because while you're planning this project and you're building and you're coding and all that, you have no idea what all the other teams are doing, and you don't know if they're how similar, or maybe they took ideas that you thought about but didn't want to do, and you get there and you get to see all that, and you start interacting with the others, see what they did, you know, some of the ideas they had, and it gives you ideas for maybe to pass on to the next generation of robot builders. And come competition day, it's a mess of the robots that work right and the robots that for some reason something happened and it doesn't quite work out so well. We ended up getting 6th because we had a very consistent robot. It may not have been the best, it was not the best robot out there, but it consistently did what we expected. Other robots had much more advanced sensing systems and stuff, but if they missed something, then they were completely screwed.
Yeah, all right. For the red, but it's usually yellow.
Now, we added the polar bear in because it kind of balances the robot and makes the, you localization a lot easier as far as programming goes. So, you know, Mr. Polar Bear really lent a big hand to our project. You know, kind of a polarization effect.
Dude, what's that thing you're holding there?
The rocket, man.